Functional programming is a programming paradigm that emphasizes the use of pure functions and immutable data. I view functional programming as the key enabler of true simplicity in software design, or phrased differently, a mechanism to avoid overcomplication. It achieves the promises of object orientation and helps make systems easier to reason about, read, and maintain. One of the fundamental ways this is achieved is simply by removing unnecessary ceremony, boilerplate code, language noise, and overspecification. In functional programming, less is more. Immutable data, a core principle of functional programming, ensures that once a value is assigned to a variable, it cannot be changed. This eliminates the risk of unintended side effects and makes the behavior of functions entirely predictable. Some languages, for example Haskell, leverage this idea to enable live caching of values returned by functions at runtime, because it can treat every function as a mapping of inputs to outputs, where after you execute with one set of inputs, every subsequent execution can simply return the same output. With immutable data, developers can reason about code by focusing solely on the inputs and outputs of functions, without worrying about unexpected changes to the shared state shared by reference. This simplicity in design reduces the potential for bugs and makes code easier to maintain over time. Side effects-based changes are limited to the edges of a design and restricted in the middle. For example, only updating a database at the end of the data processing flow, or only reading input values at the start of the execution. Again, not in the middle. Besides immutability in functional programming, functions are treated as first-class citizens, which means they can be assigned to variables, passed as arguments to other functions, and returned as results. The modular nature of functional programming encourages breaking down problems into smaller independent functions, resulting in a code that is easier to understand and test. By adding together the immutable passing of data with first-class pure functions, we achieve the ability to understand and control the flow of data through your design. Flow from inputs through algorithms into outputs. Thanks to this, functional programming bears a striking resemblance to building with Lego blocks. Just as Lego blocks come in various shapes and sizes, FP encourages the creation of small functions and snapping them together. Each function is like a Lego block, performing a simple task and having a well-defined input and output. Functions are pure manipulations of data. A good example, available for everyone to test, are the Linux command line functions. They use a pipe operator to pass data purely between terminal commands without preserving any state inside the functions themselves. These functions can be composed together, much like connecting Lego blocks, to build complex functionality step by step. And the composition of pure functions is also a pure function. FP allows for a gradual, iterative evolution towards the intended goal, while ensuring each step is working as intended. Furthermore, just as Lego blocks are designed to be compatible with each other, regardless of shape, functional programming promotes the use of simple data transformations, which do not depend on context, to act as adapters between functions which inputs and outputs might not exactly match. Pure functions do not rely on external state or immutable variables, and similar to Lego blocks can be used in different constructions without altering their fundamental properties. An analogy I often use to describe bioreference systems, which focus on direct memory manipulation in languages like object-oriented C++ or Java, are Lego blocks which, besides being snapped together, are also glued or tied together with unbreakable string. You cannot move a single piece because the whole structure might fall apart. In essence, functional programming encourages a sustainable bottom-up approach to design, which scales independently of the overall shape of the structure you build, where small self-contained pieces are combined to construct large, complex systems. The emphasis on modularity, composability, and independence from mutable state makes both functional programming and building with Lego blocks intuitive, flexible, and conducive to creating elegant solutions.